output and come back here. That's what it is. Too bad I made it almost the same thing. It's better to. Oh yeah. I hope it will work, huh? Because that's.
Sir, why didn't you connect it to
Why?
the second one, the one that leaves exit full? Should be the same.
You mean the same exit? Station exit B.
Yes.
Okay. Now the other one is working. Actually, if there is a mistake, here the mistake is station table 2 to exit. Okay. I come from here. I come from here. Come from here. I come from here. Okay. I hope there is no mistake. It will tell me if there is any mistake. It will tell me. Identifier, station exit. Okay. Close your fingers. Okay. Okay, the first one is going to table 1. Okay, we will solve this problem, huh? Because the image left. Image left. He's going to table 2. We need to wait 20 minutes. That's a lot. Let me increase it a little bit. You see that he leaves. Did you see him leaving?
Yes.
Okay. Yes. Okay. When it's empty, it's not nice. So let's do, we call it animating the resource. How do we do it? We did it last time, didn't we? Resource. When it's idle, we put a person, this person, no.
It should be when it's busy, no?
When it's idle, yeah, you're right. Yeah, I agree with you. Let's put when it's idle. Yeah. Where am I? Cancel. Where is Arena? Hey. Yeah. Okay, let me see. Window, cascade. Okay, it was here. Close it. Be careful. We should save, huh? We should save it. Otherwise, we lose everything. Just like any document. Okay, I was here. Okay, when it's I need to. This is dining. Called dining in table 1. Okay. When we put green, is it? Oh, no, we put a person. Why not a person? There's no person. Here a person. When it's idle, no, we should not put a person. I'm sorry. When it's busy, we should put a person. Here, what should we put? Put empty. Something like a box or something. Okay. This is something else. Before it was an error, and this is table 1. Okay. Let's do animate this resource. What did I call it? I called it resource table 2. I should call it the same, but it doesn't matter. Here, what should we put? Idle. Okay. Person when it's busy. Okay. Put it here, make it bigger a little bit. Okay. Hopefully it will work. Okay. Okay, he came. One left and one came, huh? Did you understand, guys? Hey, finish? You're all happy? Let's go back to our lesson, to ANOVA. Okay. File.
Are we gonna try the other blocks reduction thing?
State.
The one that I asked about.
Ah, Brahim.
Yeah.
Okay, very good, very good.
I mean, if it's gonna take time, we can like do it later, or I can try it on my own.
Yeah, but just let me explain them your idea. You don't mind. Okay?
Yeah, sure.
Okay. I think your idea is to route to the same, here is the same one. Isn't it?
Yes, so the roots are gonna be the same, and when we
Here,
put, yeah,
yeah. And here, where is the route? I'm sorry. And here, station, where is the route? Ah, the route, nothing to change. Nothing to change. And I like it, Ibrahim. Let's try it. Yes, it's working.
so the same should be applicable for the exit. I mean, like waiting and exiting, and
No. This one is better. This is it's about this is about design because we want him to leave from here. That's all. Yes, we can do. We can remove this, and then but I have to change the segment. Okay.
yeah, but it's doable, yani.
Of course, it's doable.
Yeah, okay.
Yes, of course, it's doable. Now, if you want to add a table, new table, very easy. It takes you 1 minute to add another table. Only what you did, only 1, 2, 3, 4. No, not 4. Yeah. 1, 2, 3. And you come here and you change and you say, let me copy it. Okay. And you come here and you add and you put expression and you put table 3. And then what do? You add station. No, now you can see that I have another route. Please, where is advanced transfer? Route, what is route? Yeah, it's here. Okay, and then you continue. What do you continue? Only 1, 2, 3. This one, you go to station table 3. Where is station? Station table 3. Call it station table 3 if you want. Station table 3. Do I have time? We have time, yes, still. Okay. And you go route 9, and please go tell him station table 3. Okay. And you create a process. Where is the
Also, you need
process?
to add the time.
I need what?
To add the time for the route.
Time you mean? The time, huh?
Yeah.
Yes, I agree with you. And where is the basic process? Please call it table 3. create الآخر Okay, edit, put it dining in table 3 if you want. No problem. If you want to put constant, why not? Minute, put it here. That's 30 minutes. Let's say bigger table or whatever. I'm just saying not anything. Okay. What do I need? I need connections and I need a routing the same. That's what I thank you for, Brian. Look. Oh,
Yes.
you understand?
Yeah, I get it.
Okay, let's now run it. Okay, it will not show up here in the animation, but it will show up in the simulation. I hope no mistake. Wow, no mistake. Okay. Okay, we can add now a new customer here, new route. I'm sorry, the route. It's here. Station. What did I do here? Yeah, station from what? From arrival? No, from restaurant to where? To table 3. Okay. Is that okay? Okay. Yes. I come here from restaurant. This is table 3. Okay. I can give them names here. Table 1, table 2, table 3. Okay. And I can animate it. Where is animation? What is dining in table 3? Let's say when it's busy, I put the person. Okay, it's okay. Where do I put it? Here, this person. Okay, let's run it again, Ibrahim. This is your idea. Halas, finish. Guys, are you happy? Okay, let me stop it. Let me save it. Okay, save it so I can what is save? You need to stop it. File, save as. And this is picture libraries. Why is yes, I understand it. Okay, let's put it in 953 simulation and the lectures. Put it here. They call it what is it? A restaurant. 3 tables. Restaurant what? Restaurant. 3 tables. Please, all of you say thank you to Ibrahim. Please, very nice. He made it more what is it? More efficient. Let's say less complex. How to set the working hours? Who said here? Asma Saleh. Yeah, some people are sending thank you, Ibrahim. Yeah, please. I really appreciate this because this is how to make this efficient. Actually, this is where students get 20 out of 20 and some get 16 out of 20. I'm just telling you how we mark things. Okay, Noran. Okay. One student, she said how to set the restaurant working hours. It's here. Run setup. Okay. Okay. Now let's go back to ANOVA. We didn't finish, guys. Put everything down. Everything down. What is this? This is arena. Down. Come back here. Please, you need to do this. Now let's continue. This is like a box plot, huh? This is like a box plot. It gives you all the observations or the experiments. Okay. Understanding partition of the variance. I will come back later to it. And then let's check the violations. Are you all following me? This will take me 10 minutes, 15 minutes, as checking violations of assumptions. Every analysis techniques has limitations. Okay, just like research work. Every research work has limitations. Also, what analysis techniques are. When I say limitations, that means assumptions. What are we assuming? There are three assumptions. One is normality. Second one, we call it equality of variance. The third one, we call it the independence in the experiment. The first two, normality and equality variance, I have to explain what does it mean first. We can check them statistically. The third one, we cannot check it statistically. You have to be with the person when he was doing the experiment. Why? Or by you. Maybe you are doing the experiment. Maybe your technician is doing the experiment. Okay? Okay. Long time ago, I remember when I was doing my PhD thesis, I was in Vienna doing an experiments, and the chemist, he was preparing for me the soil, not the soil, whatever things I was working with. But I was afraid that he pollutes my samples. So I have to be a chemist. I had to put my things, I have to go to, how we say, pallet pressure. I need to know how much pressure, and I needed to be the experimental. Of course, you can give it to him to work it, but since I was doing a thesis, I was a little bit careful, okay? Because any how we say, contaminations will give me errors. So you have to be with the experimental person, the technician person, and so on. For this is independence. It's not contaminations for this case. Or maybe it can be contamination, can be whatever. But we call it independence of sampling. That's that's something else. Independence of sampling, what is it? That means there is no bias when he was doing the experiment. Okay? Now, what is normality? Normality is this. This sample, it can be assumed, I said assumed, that it's coming from a normal distribution. And also this sample, that it can be, I didn't say it must be, it can be assumed that it is coming from normal distribution. And also the third sample. Did we do this in lecture 2? Yes, we did, when we used ANOVA. When we used distribution, the second lesson, didn't I give you, let's say, data, and we checked whether it's coming from a normal distribution or whether it's coming from, let's say, exponential distribution or from a Wimborne distribution? We did this, didn't we? We did. And I think it was giving us even p-value. You can do that. You can use ANOVA to do that, but we are not going to use ANOVA. We're going to use R. Whether we can assume that this one and this one and this one, each one of them is coming from where? From a normal distribution. That's normality. The second one is equality of variance. What does it mean? This is equal var, the sample one, huh? That this one, these three variances can be assumed that they are equal. Of course, this is simple variance. These are simple variance. But can we assume that they are equal? That's statistics. They don't look like they are the same. They don't look like they are the same. Can we assume them? That's statistics. This one is using Levine test or another test maybe. Normality is using Shapiro test. These are scientists, statistical scientists. they have developed a test whether you can assume normality, and also Levine and another scientist also different tests to test what equality of variance. So let's do it one by one. Equality of variance and what? So the first thing, let's go to here. You put your hypothesis. Checking equality of variance. Here I'm using Bartlett test, not what is it? Levine. It's okay. Bartlett test. It's okay. The most important, you put your hypothesis. No significant violation of equality of variance. What does it mean? That means you can assume. Here, I will write it in a different language. We can assume no. What is it? Equality of variance. Equality of variance. Sometimes we call it homogeneity of variance. Here, there is a violation. That means you don't use ANOVA. I know, Ibrahim, he will say, what do we use? Are you listening, Ibrahim?
Yeah, I'm listening. I'm following up.
I'm sure you will jump and you say, okay, here we cannot assume. We cannot assume what? Homogeneity of variance or equality of variance. Same thing now you do the statistics. That's what's the beauty of statistics. So many techniques. The logic of rejecting, not rejecting is the same thing. You run the test, okay? You run the test. You don't run ANOVA. You run for this problem. You run Bartlett. You run what? Bartlett test. If he gives you p-value greater than alpha, you cannot reject the null hypothesis, and you say, I am happy. I can use ANOVA. Otherwise, your research is not right. You are doing wrong work. What do we use? We call it non-parametric techniques. Non-parametric techniques. What does mean parametric? Parametric, that means it's assuming some distributions. And we told you the p-value is obtained from the F distribution. No need to put you into this problem. Just this have to be checked. In your thesis, when you do your thesis, be careful. Any of your professors, when he watch you, and you tell him I use ANOVA, he will tell you, hey, did you check the assumption? If you tell him I didn't check it, that's I don't believe your results. I don't believe your results. Okay, so we cannot assume equality of variance. Okay, let's do it. Is it okay? Copy paste. Hey guys, is that okay? Let's go to R. What's the p-value? Let me ask students here.
It's very high.
Please, all of you, I lost my participants. Let's see my participants. It's here. Here. My participants. Khaled. Khaled. Did you go sleep? Khaled. Where is Khaled?
Yes, I'm here.
Okay. What do you see? When
The p-value is
huh?
the p-value is 0.4306.
Okay, what does it mean?
It's higher than alpha, so we fail to reject the null hypothesis.
So everything you are saying is right. Complete.
Yeah.
So
the variance, we can assume that the variances are the same.
you can assume that the three variances are equal, huh?
Yes.
Very good. Very good. Just to make sure that you understand, and also it's good to have interactive way of effort. Guys, I want to share something with you. It's very important, this interactivity, because I am feeling that you are listening to me. I wish I'm also listening to you. Now, if suppose everyone leave this chat room or this online, believe me, I will be the worst teacher.